Ladies and gentlemen, as Elena just said, we are only 1 week away from the most wonderful time of the year. Welcome to the season finale of the online technology meetings of EPIC. Welcome. So what's on the menu for December 16th? Wait a minute. Before I reveal what's in store for the final online technology meeting of 2020, let me say a quick thank you for actively contributing to over 300 hours of deep dive discussion in this very bizarre year. Your willingness to share proves the power of EPIC and our EPIC question. What can you do for others and what over 630 EPIC members can do for you? So from everyone here, thanks for being EPIC. So now, where was I? The holiday season brings out our appetite for delicious food and beverages. There is no better time to understand the unmet needs of photonics in groceries. From consumers' interest growing in what's really in the shopping basket to the pressure on industry to reduce the environmental impact. So let's ask the epic question to the big brands, and I mean the giants like Unilever, PepsiCo, Heineken, Jotis or Tetra Pak. Have you seen what natural machines are up to? 3D printed food is already on the kitchen table. Soon, my daughter will download the best Christmas turkey recipe by Jamie Oliver and have it printed at home. Maybe that goes too far. How about these delicious Oreo cookies? They are made by the giant Mondelez, who is exploring high-end photonics spectroscopy solutions for the real-time monitoring of the process. So help us make Wednesday, December 16th, one of the most tasteful events in this year's calendar. Dinner will be served at exactly 3 p.m. Buen provecho, eat smakelek, bon appetit. It is exactly 3 p.m. in the beautiful city of Northbank, just to the sea. And I'm super excited, Elena, what's going to happen this afternoon. Really excited. I'm going to start by telling everyone that Today is very important. 659 members are extremely excited to be part of this association, and they contributed to the whole season 2 of EPIC Online Technology Meetings. Today is our last event of this season 2. We covered the entire supply chain of what we consider the hottest topics in photonics, and we got amazing feedback from all of you, which gave us a lot of energy, and we're going to continue going because we already announced the topics for next season 3, and we're covering everything. For example, pay special attention to the meeting that we have on the 22nd of February. We are talking about agri-photonics, a huge market for many people that today are in the room. And also, today I also have something big to announce. Nobody knows this. EPIC is also going to connect the quantum industry on 2021. These are the 6 first online technology meetings. We call it quantum technology meetings, that we're going to cover everything in all the key application fields. And we're going to look for the end user. So if you're an end user of quantum technologies in security and defense, healthcare, e-mobility, communication, or any other field, we are going to be knocking at your door, but make your life easier and our life easier. Knock on ours. We are going to have to include all the potential end users on these key markets. And today, in the season finale, I would like to remind that I'm just talking on behalf of an amazing team of experts in EPIC, half of them with a PhD, who have spent an amazing 2020 looking for the end users. It was a very difficult year for everyone, for the whole industry. We did our best to give the people the feeling that they still can connect. We are going to continue in 2021 organizing events, providing access to the network, helping people raise capital, managing the biggest website to find a job in photonics, and of course, keeping market reports as one of our key values for the EPIC members. But today is about the food and beverage market. I would like first of all to acknowledge AZO Sensor. Thank you very much for being our media partner, and thank you very much for promoting this event in all your media software and magazines. And also let me And let me thank our sponsor today. This meeting would not be possible without the sponsoring of NTS Optel. All the way to the Netherlands, NTS is one of our key system integrators. NTS Optel helps people with the test and with the subassembly and system engineering of any optical instrument in any application field, but today they are very interested on the food and beverage sector. And with this, I would like to give the floor to the person who worked the hardest of this meeting, Elena Beletkaia. Great job today with all the end users addressed. What's in the menu?
Hi, Jose. Thank you very much for this introduction, and extremely excited to be at this meeting and to hear everything what was going on what is going to be happening. We will hear today everything, what are the challenges of the food industry and a number of solutions. Moreover, in the room today with us, we have the whole supply chain, we have the end users, and we are eager to understand their needs and their demands. And along with that, we also have companies who are providing various solutions. Of course, there is a lot of R&D in the room because this is still emerging a topic, and there is a lot to know how to do. There are a lot of sensors and cameras who already provide possible solutions, as system integrators, light sources, photonic components, and all other parts of photonics, which can come together and give it the best of the solution to make our food and beverages safe and as tasty as they can be.
Thank you very much, Elena. This is a lot of work. Elena worked really hard on making sure that every company today that is in the room and in YouTube have access to the potential partners, suppliers, and customers. We're going to connect all these companies. Great job, Elena. This meeting is actually live streaming in YouTube. So let me say hello to the YouTubers. Hello, YouTubers. How are you doing? If you want to get in touch with any of the participants today, you have the participant list down there. If you scroll down in the YouTube web page, you have the participant list. If you want to get in touch with any of the participants today, send me an email, jose.pozo@epic-azoc.com. I will be more than happy to introduce the partners. Also, make sure that if you have any questions, you post them in the chat in the YouTube. I will read them in the room. And the same thing goes for the people in the Zoom room. If you want to get in touch with each other after the meeting, send me an email, jose.pozo@epic-azoc.com. During the meeting, use the internal private chat to talk to each other. You really need to make business out of this meeting. And after the meeting, we'll finish exactly at 5 o'clock. Exactly at 5 o'clock. After the meeting, we stay and we have private one-to-one meetings. That's of course fully voluntary, but if you stay, we'll have private one-to-one meetings so you can privately meet your potential partner and discuss the business opportunities that this market enables. And with this, I would like to start the ball and start the meeting. Thank you very much, everyone, for being so excited, half excited as I am. It is almost Christmas. Let's go first to Campden. This is one of the central locations for the manufacturing and certification of food and beverage processes. We have Martin Whitworth, the principal scientist of product innovation at Campden, to kick off the meeting. Martin, thank you very much for being with us. The floor and the attention of everyone in the food and beverage supply chain is yours.
Thank you. Let me just share my screen then. Is that working?
Yes, crystal clear.
Yeah. Okay, so thank you for the introduction, and thank you for the invitation. We are not a photonics manufacturer ourselves, but we at Campden BRI, we are a provider of technical services to the food and drink supply chain. So we do testing, consultancy, product development, innovation, all those sorts of things. And we are really well connected with the food industry. We know their needs. We talk to loads of them. We have them as members. So we are in a really good position to apply technologies and to identify what's coming and what will provide benefits for our members. In that context, we're very keen to work with photonics manufacturers if you've got solutions to the sort of problems I will present during this. We are a user of photonics ourselves, so there's a long list there of technologies that we use in our own labs, mainly for product characterization and analysis. I, for a while, built up and managed our imaging lab, so many of those are technologies that I established. We were among the first to apply many of them to food, so things like hyperspectral imaging, calibrated color imaging, we were the first to do it. We promoted what it could do, and it's now widespread. And my current role involves very much more of that sort of thing of trying to identify new technologies that can give benefits. So I thought I'd give a little bit of a summary, but many of you probably work in this area, but to give a summary of the sorts of areas in which photonics is used in the food industry. And it's basically throughout the whole chain, from farming, food to fork, farming through to the consumer. And very nice, Jose, for you to say that there will be something on agri-photonics coming in February. So precision agriculture, loads of cool stuff going on there. We do a lot in the manufacturing area. Photonics are used in raw material characterization, final product, and also in controlling the process, guiding robotics, packing, all those sorts of things. And also outside the factory gate in regulation and supply. So retailers, regulators want to be able to inspect products, and photonics is a lot of the technology that's used in that. So coming on really to what the challenges are, part of it is taking those sorts of things that involve what we do in our labs, or that involve taking a manual sample and doing a chemical assay and trying to put that online in food factories. It gives efficiencies and automation, but a really key benefit is it gives you continuous inspection, not just every half hour or something, and that gives you better validation and assurance, which is crucial in this industry. So technologies, and a lot of photonics helps with that solution. So things like moisture and fat are now mature technologies done with NIR spectroscopy, been done for decades that way. Color and temperature as well, those are things photonics can deliver. But what about more complex chemical analyses? So not just fat, but different aspects of fat, saturated fat and things, and other chemicals. It was bulk fat in homogeneous materials. Now we can start with hyperspectral imaging to do distributions as well. That's kind of emerging now. Some of the more advanced things we do are things like structure. We have micro CT in our lab and microscopy. How can you put those sorts of characterizations online and not just in product development where we use them? And a practical thing that a big sugar manufacturer has posed to us is, if you've got a big tank of sugar crystallizing, how do you measure particle size in the bulk tank? We can do it by taking subsamples off, but how do you do the complete inspection? Food safety is crucial. There are lots of regulations and controls that apply to make sure that if consumers are eating food, it is safe to eat and they're not going to get ill as a result of consuming it. We use lots of thermal processes and other things to reduce microorganisms and control them. Photonics are part of the processing, and we do a lot of research on technologies like UV and pulse light, but it's not complete yet. There are still developments to be done, and we're very keen to work with people on that. Inspection as another aspect. So you can see a picture there of someone taking a swab. There are rapid tests, but it's a point measurement. How could we scan an entire conveyor belt and see if it's clean? Maybe some scanning or imaging technology can help. What about inside pipework and inside process vessels? A bit more of a challenge. Another application, foreign bodies, things that shouldn't be in the food product when it goes out the door. We have loads of controls to make sure that things don't get in there in the first place, to prevention, but we also need inspection. We can detect metal or many metals with metal detectors. We can use X-ray for dense materials. Maybe things on the surface we can do with imaging, maybe with hyperspectral. But what about things like bits of plastic or wood or something internal in the product? We are lacking technologies. Photonics may be part of the solution, and we're doing research on that. We welcome anyone who thinks they've got solutions. An example there showing a very new tomography system that we've evaluated, showing little bits of glass inside a glass jar. Not just foreign bodies, but defects like holes in loaves of bread, for example. Could we detect those online and reject them? Rot in fruits and vegetables, raw materials. And another aspect is supply chain validation. So things like authenticity. Is olive oil genuinely olive oil? How do we inspect it? Spectroscopy is a lot of the solution. Things like Raman can help. Freshness. We've done work on, for regulatory authorities checking, is fish fresh? How old is it? Can we inspect that with photonic technologies? I give a couple of examples there. Herbs and spices, hyperspectral imaging, and the example I show with little sort of handheld NIR sensors may be part of the solution. Raman spectroscopy can look at authenticity of drinks. It can even work in the bottle. These are all the sort of research areas we're working on. So lots of opportunities there. We know the food industry. We are well aware of their needs and so on. If you've got technologies that can help with this, we are in a good position to help you apply them, and we'd love to hear from you and work with you. Thank you.
What a great overview. Thank you so much, Martin. It's so much information to take in, and there are apparently so many challenges in food and beverage industries which needs to be solved. And I hope that maybe we won't solve all of them today, but we will hear a lot of solutions. We will have a lot of different technologies and addressing different parts and different challenges which are in there. Even though we had like 3 slides of challenges, I would yet again come to you with our favorite epic question. So at the end of the day, what you can do for them and what they can do for you when it comes to food and beverage.
Well, I think what we can do is identify what the needs are and help you evaluate under realistic conditions how your technology can deliver benefits for the food industry. We can connect you with users, and we can, you may not have the ability to do the reference tests or to know exactly what the requirements are. We can take your technology, trial it in our pilot plants, and help work with you to deliver it. And we can get you an audience as well. That if you've got something that delivers benefits for the food industry, we can get the message out and help you. So that's our aim, is solving problems for food companies, and we're keen to work with you. What you can do for us, well, as I say, our clients, our members, they're looking out for solutions for things, and we're working on them. If you have the solution, tell us.
That's great. We have Frank from NTS Optel. I think he might have a solution. Or Frank, share with us about NTS Optel.
Yeah, of course. Let me share my screen. Can you see my screen?
Not yet, but we can see you very well and hear you loud and clear.
Okay, you cannot see my screen. Now, what I then maybe I can, or maybe I should do it in this way. Share.
Yeah, now we can see it.
Can you see it? I try to go to presentation mode. Can you still see it?
Yes.
Well, what we basically do is develop, produce, and assemble and test complex optomechatronic systems, and we indeed also apply them in the food industry. We are a fairly big company based in the Netherlands. Let me skip this one. This is basically all the things that we do. We do the ray tracing. We use all kinds of optical techniques, indeed also spectroscopy, Raman spectroscopy. So I think that would be really good for this one. We deliver complete solutions for this. We have our own optical labs and electronic lab. Just go over it very fast. So we are a pretty big group for this one. And now some of the examples is that we already make a curved firmness sensor for dairy, for cheese making, where we can really measure the near-infrared reflectance spectroscopy. Make these kind of things to make sure that there is a good correlation. We, for instance, make thickness measurements in harsh conditions for the Pringle potato chips. We do the spray monitoring in milk powder production, and these are just a couple of examples of the things that we can do. And well,
those are really great examples. Thank you so very much for sharing it with us.
Yeah, so Martin, you said a lot of examples, so dozens. So yeah, I think we should get in contact to see what we can do for you. Huh?
That's good.
Perfect.
Yes, I'd love to.
Great. For sure. One-to-one meetings, after the meeting follow-up. I also see some other comments popping up. We have with us today in the room Ugur from PepsiCo. He agrees with the challenges presented by Martin. Would you like to maybe share a little bit more on what is your view on what is the most challenging in the food industry from PepsiCo side? Ugur, would you like to share with us a little more what you think about it?
Thank you, Elena, for the opportunity. I think when Martin was presenting his slides, there were reference to the technologies that have been unlocked, and there were reference to the technologies that could be unlocked. Yeah, and I was given that we produce snacks, beverages, as well as dairy products. I was looking at the immediate applications from our end, and I have listed the top 3. Okay, which could be online salt/sugar. Okay, measurement. Online, please. The idea of inspection of cleanliness online, not a swab but an online solution, and the authenticity, for example, for milk-based products or some oils, etc., could be a really good application for us across our facilities, if it makes sense. Yeah.
Perfect. Thank you very much for sharing with us. We have many more questions in chat. We have a question from Jan and Mike. So Jan from KLST and Mike from Teledyne. They have similar questions. Let's hear maybe from Mike first.
I was just agreeing with the comments in the chat about you know, how much is the food industry willing to pay for improvements and solutions? It's always a challenge from our side when the customers need higher quality, faster speeds, greater color accuracy, and so on and so on. But the price always has to be lower. So it's a very interesting challenge for us as well.
Well, let's see. Maybe we can find solutions there as well. Martin, do you have any comment on that, or maybe Ugur has a comment
I
on
suppose
that?
in any industry, yes, cost is part of it. The food industry is the biggest manufacturing industry, certainly in the UK, and I suspect in most countries. But the margins are tight. Nonetheless, if a technology delivers benefits, then people are willing to pay for them. Safety is always the sort of fundamental, because if there is a technology that means safety can be improved, regulators and retailers and customers will soon insist on it. So companies will be required to do that. They may or may not like the cost, but it's going to become essential. So if you can do a safety benefit, you've got a market. Quality, that's all about differentiation and what sort of benefits and gives, and whether they can sell their product for more and deliver value as a result. But technology is coming. Many things have already arrived.
From my perspective, Martin, fully agree with the safety and quality elements. And if I can add one more element, which is, I think, productivity. Yeah, if, for example, there is any technology that can help us minimize labor, for example, or minimize the waste, or see the waste as early as possible. Okay, so kind of optimize the waste, and of course, we will be in a much better position to justify those technologies. Yeah.
Okay, thank you very much for all the input. And we already heard a little bit that it is also quite important as a cleanness of the production line. And also there are a lot of things that can be done on the production line and improvement of its work. And today with us, we also have Paul from Marel, Innovation Category Manager. Paul, why wouldn't you share with us what you have prepared and what Marel has on offer for food industry?
Yes, thank you, Elena. I will share my screen now. And when I'm not mistaken, you should see the...
We see the screen, and now we need full presentation mode.
Yeah, that's correct.
Yeah, that works great. The floor, the attention of everybody is yours.
Yes, first of all, on the side of EPIC, thank you for the invitation. Since not everybody knows who Marel is probably in this meeting, let me shortly give a short introduction about the company before I dive into the presentation, because we didn't include, I see that we did not include a few slides on that as like that has been requested. Marel is a full-line supplier in the meat, fish and poultry processing industry. We supply to customers around the world solutions, full-line solutions to the meat processing industry. This goes as far as for example, the chicken nuggets production equipment and so on. We have a lot of challenges in relation to food safety, which I will present in the meeting. And we have about 8,000 employees worldwide working for us and supplying companies with also software and full integrated solutions. Now I try to go to the next slide. Okay, that seems to work. Yeah, just diving in with a big challenge that we face is biofilm forming, of course. That's a very large problem in the whole food industry, in the whole food chains, and the specific thing is that once biofilms form, they are about 10 to 1,000 times more difficult to remove. So there's a big challenge of keeping food safe by introducing technologies that lead to less, for example, bacterial attachment, or that disrupt by other means the process of biofilm formation. Well, some work in progress is that if you look at the light gray area, those are from our customers' perspective the topics that they are looking on a daily basis, and we try to serve that as good as possible. One example is, for example, that we are looking into the adaptation of surfaces, that we in future are able to supply, for example, surfaces that have a topography on a soil specific or application dependent basis. This can be a superimposed surface like you see on the right side of the screen in the dark blue area as a combined profile. And we are also looking into enhanced type of stainless steels with a higher copper content, for example. Well, when it comes to bacterial adhesion, many of you know how this process unfolds. But what you see on the screen on the left side is a 25 micron size page, and this is below what the naked eye normally can look. This would be about 50 microns. On the right side, you see how bacterial attachment takes place. So there's a high affinity for microorganisms to clump together in scratches and crevices. So this is why we are slowly departing from the position where we are not in control of the surface. For example, the glass bead blasting leaves a surface with scratches and crevices, and today it is still the most suitable and technology which is used all over for non-food contact surface, I must say. In future, we could also take the technology, for example, laser-based technologies, to a new level. Once they become fast enough, and that's now on this moment already taking place. So laser-based surface texturing is you can apply it a couple of 100 times faster than a couple of years ago. So it's really picking up, and this gives companies like Marel trust and confidence that we can use it also in future within our supply chain. On the top left side, you see a magnified picture of a belt, of a conveyor belt, and in fact, that's you see also the micro scratches which has been done by micromelling. So in future, we look forward to introduce superimposed surfaces that you see on the right side of the screen, where a rough profile, so the macro profile you see, is being used, and on top of that a microstructure which is used for example for cleanability and for reducing bacterial attachment, for example. Well, the driving forces in our industry, there is a growth in recalls that's partially because of the more output in terms of food production, and the second one is mainly because of faster detection methods. So there's also growth awareness of that. So those numbers you have to look at it from that perspective. Traceability, of course, will be will become a lot more important. On the side of consumer demand, you have awareness and access to information, which is continuously growing. This is also a driving force for solutions I talked about. And then we have the governmental scheme, for example, DALIS, that's Disability Adjusted Life Years, how the European Union translates that. And this is, in fact, when people get sick from food, how many people are not productive, and what are the costs involved. So there is also a big driver there, and that's why it has been a horizon pillar. Then we have the food, the value chain, of course, like companies as Marel, that we want to be at the forefront. Sometimes, we succeed in that, sometimes not. But at least we are researching technologies which can provide Marel a competitive advantage. Those are the things on the screen are not all of them. There are also other dimensions like supply chain complexity. With this, I mean, for example, that new technologies, for example, other blasting technologies for a surface or finishing surface treatment technologies. Yeah, especially with a company as large as Marel, we have well over 1,000 suppliers on surfaces, for example, and deviating from a more standard surface what we apply today to a new one can take 5 to 7 years, for example, this transit period. So it's quite complex to accomplish that, and also quite costly. Then we have the regulatory aspects. Those are constantly also adapted and changing, and this is providing an extra dimension of complexity. And then we have also a big one is standardization. For example, if you look at the surface and the properties, and we are talking about an array value, which is on this moment for food contact surfaces mostly applied or demanded from our customers based on a roughness value of 0.8 micron. Well, looking at the picture, those can be 0.8 micron. So there's a large challenge to accomplish deviating from an array value as such. Yeah, then the last but not least, we have the market acceptance, that this also has already been indicated in this meeting. As long as there are many people who are looking for the best pick and are not willing to pay a higher price, for example, for the product, this is also hampering technology development. Photonics at Marel. We have a number of technologies that we apply, and today I'm going to explain a little bit about the future landscape, also what we today already apply for contaminant detection, for example, and fat analysis. Also coloration is something we measure on quality grading, for example. But we also have the manufacturing scheme. For example, if we produce our equipment, where can photonics, for example, laser-based technologies help us in future? Then we have the technologies that we are looking at. How can they become potentially interesting for to research them within R&D? This is something I can hopefully reply to you when there are some questions about that. If you look at for example, terahertz imaging, we are interested in looking into that for ceramic layers, for example, as opposed to what we now today use as metallic layers for more to improve our products from on for example wear and tribology. We have laser-based technologies where we are currently looking into for beam shaping, beam splitting, for example, beam interference, and a number of technologies more. One example is direct laser interference patterning, which can be quite interesting for us in future, or combinations thereof. And with that, we aim to adapt the wettability, cleanability, adhesion and retention, and biofouling of a surface. Next to that, we have hyperspectral imaging, multispectral technologies, and of course, optical coherence tomography, for example. Well, if you tend to reach out for Marel, this is the last thing. The yellow blocks, of course, all the technologies which you see in the orange circles, they need to somehow to connect to our daily applications and to the challenges our customers face. The challenges on integrating new sensor technologies, we have a few of them, though this is not a complete list, but the most important ones you see now on the screen. It's production. Of course, we need to scale up when the time comes. It must be cost effective. The usability and reliability in our industry at our customers within the environment of our customers is an important thing. And we have, of course, data management. And this is also still a big challenge to have the right algorithms, the right models, the right type of software to apply that in our industry at our customers within our domain of application. Well, the diffusion of innovation, of course, we have EPIC and the members and participants of today, for example. That's an important thing. Then we have the platforms I just explained, and that's important for us to mastering the key directions on photonics and to set our directions for near future. Of course, we after that we can team up and assess, for example, with academia and with companies around us on our way to making an evolutionary plan. Tombra is also joining, I believe, today, and we have created a strategic partnership with Tombra, for example, for sorting solutions. And this is important for us to at the end transfer it within Marel to the right type of industry and to connect the solutions to the desire of our customers. And this is on our way to market diffusion. Yeah, with this I came to the end of my presentation. I will stop sharing if there are any questions.
Thank you very much, Paul. You know what? I went to visit Paul. At Marel just before the whole world fell apart. Thank you so much. That was such one of the most impressive company visits I did last year. And I really am happy that you're here talking about these particular challenges. You talked in the past in a previous meeting about the need for laser surface structuring. And I know that many companies have been in touch with you since then. We talk also about the SWIR, the shortwave infrared detector cameras. And I also know that many companies have been in touch with you. So you have been one of the key entry points for this industry. Thank you very, very much. And if you want to be amazed of what Marel can do, actually, it's better if it comes from your mouth. Can you give us the impressive number of the highest throughput of chickens that can be processed in a Marel machine?
Well, we have one example is a Korean company which has 5 processing lines on top of each other. And one processing line is the larger ones are today capable of have a slaughter capacity of 15,000. So that means an output of 60,000 chickens per hour is possible. Yes, that's
you heard well. You heard well. 60,000 chickens per hour. It is out of my mind, and it's quite an impressive. Quite an impressive part that you're here looking for collaboration. So if anybody has technologies in the shortwave infrared or in the laser surface structuring, they are willing to test. And this is one of the leading companies. We are really lucky to have you. I'm going to have a little bit of a round now because you already have 3 of the end users. And I want to go back to our representative of PepsiCo in the room, Ugur. Thank you very much for being with us. Thank you very much for PepsiCo being represented at this meeting. In the previous intervention, you said a lot about the process. You have many companies here who do hyperspectral imaging, who do shortwave infrared, long-wave infrared, and they have the same question I have, which is what process needs to be real-time and what processes don't need to be real-time? Are you looking at having every single test on real-time in the process monitoring?
Thank you for the question, Jose here. I think, of course, not everything has to be real-time, but given our recent digitalization and automation efforts across many different parts of our processes, and given the fact that we have been deep diving into this for a certain amount of time, I think on time or real time, information can really help with the efficiency of the process, especially for the processes that have quite a lot of variability. Yeah, for example, I think in one of the presentations or in one of the previous slides, we saw some reference to dough manufacturing. Yeah, so for example, the moisture of the dough is quite variable. Yeah, if you, for example, if it's taking you 10 to 15 minutes of time to read it, go to a lab, get the information and come back and do some adjustment based on that, you might be doing your adjustments into a already changed process, okay? Because the parameters might have changed due to any reason, so you may not be achieving a center-line process, yeah? So if I can make it in simple words, I think a real-time or online measurement of the critical process parameters can really help from an end-user perspective. Yeah.
Peter Totrup from NLIR. Is that the kind of answer that you were expecting? That all the process monitoring, by the way, NLIR is making fantastic square detectors. So I want to hear from you. You have been interacting with many end users in the agriculture and in the food and beverage. Peter, how do you feel about real-time process monitoring versus not real-time? What kind of application fields is NLIR targeting?
So I'm on now. So we are targeting companies with inline online. So we have done that in fermentation and bioreactors. We have done it with also in liquids, alcohol and sugars. So we see a lot of interest in this very many samples all the time. So we see inline and online as a new trend. You go from the old ad lines now into inline. So we see that a lot.
I'm going to have to introduce you to many of the people today because you really have something that they need. But before that, I'm going to go to one of the most innovative companies we have in EPIC, is Xenorics. And I have a question because Xenorics, you had a question, Robert, you had a question for Martin. And I think it's a very important question. I want you to bring it back. What's on your mind?
Sure. Yeah, the question is basically, when we deal with
Can you speak a bit louder? We really want to hear this question.
Okay, sorry. I said when we talk to customers, they also inquire, just like Martin said, concepts like quality or like freshness that are really man-made concepts. You know, you and me, we have a intuitive understanding what that actually is, but even though we talk about the same thing, doesn't mean that we actually mean the same thing. So I was wondering if any of you, maybe Martin, has come across a definition that everybody can agree on, what that actually is on a photonics relatable level, you know, so that a spectroscopy, a Raman or FTIR or whatever it may be can actually answer this and we can immediately agree on what we talk about. So this is basically a question, have you come across a consensus on the definition of concepts like quality or freshness or ripeness or these kind of things?
Is there a parameter that we can measure somehow with a Raman spectrometer or a hyperspectral camera that says that the food is fresh enough or has the right quality? I think that's what we are missing in this particular supply chain.
Shall I have a go at answering?
Yes, please, Martin, go.
Yes, so of course we can make objective measurements of, you know, how long was it since someone asked me about fish, since this fish was harvested, was caught. But supposing we froze it, well, the shelf life is longer. So then it does get complicated. We can make objective statements about how old it is or what condition it's in. But ultimately, sort of quality comes down to what the customer is looking for and what the brand owner is trying to produce. So quality is really down to a product that you can produce and sell cost effectively, profitably, and that your customer wants. And it varies depending on the product. It varies depending on the market. We have a huge consumer and sensory science department to ask consumers what it is they want.
No, but this is very important. So there is, for every product, for every food and beverage, there is a set of specifications that companies who manufacture cameras or sensors can look at and say, okay, we can manufacture a camera like this for real time or not real time, and ideally for the right price and size. Is there some kind of specifications for this?
Well, of course, there are so many foods and drinks, and they've all got loads and loads of specifications. Some of them are official things, or if you want to sell them into a certain market, you have to meet these criteria. So, you know, if you sell long grain rice, there is a definition in a market of how long is long. But if you're selling things to Tesco's as a supermarket in the UK, it'll be down to what Tesco say their customers want, and they will set a specification. It will be different to what Sainsbury's say. Some of the core things will be the same because that's what regulators want. You know, if PepsiCo are buying potatoes to make crisps, well, they will tell you what quality they want, and you will have a defined specification. But photonics is really useful in giving, once you've agreed that specification, in both of you being able to measure and agree it and say, have I met it?
That's exactly the question I was, exactly the answer I wanted from you, because for every different process, there are specifications, it's clear, and we really want to match them with technology. So let me go back to Marel, because there is a question for you from a fantastic company in Belgium called Caleste. Jan Vermeeren, first of all, thank you very much for helping us sort out this meeting. Thank you, Jan. What's on your mind?
Okay, good. Yeah, my question to Paul was, do you see also perhaps a future in, say, smart tags, which you can, let's say, protect or hide below price tags on packages and look through the packaging material to the quality of the material? You see future in such type of applications?
I believe you just, I just replied to your question, which you typed in. We are not supplying packaging solutions, but we are working together with integration partners on that. And for as far as not already on our, let's say, that is, those solutions are not visible to us. It's always possible to reach out to us and that we can forward your information that you might have or your questions to integration partners.
Okay, fine, certainly do.
Thank you very much. And let's continue with the program. Now we go to AINIA. Ricardo Díaz Pujol is here as the head of Intelligent Automation Department to tell us how the supply chain of EPIC can make you even better than you already are. From all over the world to AINIA, the floor is yours.
Thank you for your invitation. One moment, please.
We see it, we hear you, everything is great.
Perfect. Well, let me share a few words about AINIA. We are a Spanish technology center with over 700 member companies and more than 1,600 clients. Our mission is to give value to companies by leading innovation in the food and agriculture sector, but also in environment, packaging, and cosmetics. What we do with photonic technologies? For us, for AINIA, photonics are a key technology to try to solve problems that company can't afford with conventional methods. We use photonic devices able to measure properties of food and beverages that can help us to take decisions. A very powerful technique for us is, for example, computer vision, using images from different sensors, able to detect properties that cannot be detected by human eyes, combined with advanced techniques in image processing, like, for example, deep learning. We are using fluorescence, NIR imaging, laser vision, multispectral vision, thermography, or terahertz. Some applications or success stories I want to share with you. For example, we have been developing fruit sorting machinery to classify fruit according to its external quality, detecting defects and physical deformations using machine vision and laser scanners at very high speed. For example, 12 fruits per second and per line in a machine. Or another application, a sorting machinery for the inspection of mussels. The system is based on a multispectral imaging in the visible and infrared spectrum with automated rejection of defects and contaminants. Or, for example, we find many machineries to inspect the bottle outside. But what is important is the contents, the wine. We have developed a solution in collaboration with a Spanish machinery manufacturer to detect foreign bodies inside the bottle, glass fragments, cork particles, or insects. Or, for example, another solution based on thermography to detect defects in the sealing process of packaging food in plastic trays or thermoseal bags. This solution can detect leakage and reject defect packages from the food chain to prevent products in poor condition reaching the consumer. We are also using spectroscopy because This technique allows us the measurement of the interaction between infrared light and food to identify chemical compounds or its concentration. We are applying conventional spectroscopy to measure a sample in one point, but also hyperspectral vision when we want to measure the whole sample. Some examples or application you can find is, for example, the detection of foreign bodies of low density. This is a common problem in food industry because X-ray or metal detectors doesn't work. In raw products of a small size, like nuts, for example, hyperspectral vision can detect contaminants with the same colors if the composition is different, thanks to the analysis of its fingerprint. In this image, you can see a sorting machine able to detect small contaminants at a production rate of 1.5 tons per hour. Or, for example, the inspection of internal quality in fruit to measure the maturity. Spectroscopy allows us the measurement of the sugar contents or acidity. Or using also hyperspectral imaging as an instrument for do measurement in real time, as if we have a lab online. In this example, this is an application in a bakery company measuring composition to tune the fabrication process. Or we can also use photonic sensor devices combined with mobile robotic platforms in precision farming, because these techniques allow us the characterization of plots of different crops to optimize fertilization, pesticide treatment, and the harvest, reducing costs and waste. Conclusions. Well, we think that automation and artificial intelligence are powerful tools, but to take decisions, we need accurate information about products and processes. Then photonic is a key technology to improve food quality, safety, and production. And also consumers need to know more and more information about what they eat. And I think also that cooperation is crucial to have a competitive market in Europe.
Thank you so very much for this great overview of different capabilities of AINIA. And you highlighted a little bit of what photonics technologies can do for food industry. But if we go back to EPIC question, so we have a full supply chain of a photonics industry here in the room. So what you can do for them and what they can do for you?
Yes, I think that cooperation is crucial. So there are. I have shown you some problems, some examples applying these technologies, but there are more and more challenging problems we have to solve. For example, related with safety. In the case of safety, food safety, the determination of contamination in products is a problem that companies need quick, fast methods to detect contamination, for example, or also to assure to the customers, to the consumers, that the food or the beverage is perfect to be eaten. So in this line, I think that cooperation is crucial with technological center, universities, and also instruments manufacturers, and of course the final users, because they have to validate the solutions.
Sure, thank you very much. You also in your presentation talked a little bit about packaging and plastic, and with that I would like to introduce to you Felix from trinamiX. Felix, could you please tell us a few words about trinamiX and what solutions do you offer for food and beverage industry?
Yes, sure, I'd love to. Let me just share the slide I prepared. So basically, one thing we do at trinamiX is to provide a spectrometer, a device that gives the chance to use NIR spectroscopy throughout the whole value chain. So idea is that we have developed this handheld spectrometer. It's like the size of the very first satellite phones, I would say. And it should give everyone the possibility to use NIR spectroscopy from farm to fork. And what we do with it is that it gives you a spectrum, a near-infrared spectrum, and will transfer the data directly to the cloud, where we apply chemometric analysis and give the user the feedback immediately within seconds about this analysis. And in the area of food and beverages, we've already published or given the users 2 use cases. One would be coffee, where we have established an analysis method where you can instantly determine the caffeine content in your grounded coffee powder, which tries to bridge a little the gap between the smaller manufacturers that don't have the capacities to use lab spectrometers or inline apparatuses. And the other thing that you mentioned, Elena, just is a thing that is not directly a food topic, but very important too, is the packaging, because our spectroscopy solution is able to detect the type of plastic. And this is something very important for recycling, because once you create packaging, or you have you're developing a packaging, maybe also mixtures of different plastic types, you want to know, is this something I can recycle? This is important for the manufacturers and the recyclers too. So our solution will give you the spectrometer, you put it onto your plastic packaging, press start, and will tell you if it's like polyethylene or PET or anything else.
Great, thank you very much for this overview from trinamiX and great technology. Interesting question for me. So, as it's a handheld device, and you developed it now for few applications. If you go further, is it something which can also go to a final consumer? So, can I maybe take it with me to the supermarket and check how good is the food on the shelf?
Yeah, absolutely. That's absolutely the direction we're going to, miniaturizing it even more to put it in everybody's pocket. And we're also working on that together with Qualcomm to put it into a smartphone at the end. So everybody can use it right away. Maybe in the supermarket, test if the food is fresh or not. Or also in different sectors. So this is where we are absolutely heading, to make it small and make this scientific question available for everybody.
Okay, thank you very much. We have some more questions. We have a question from Jan from Kailastic, back to Ricardo. Jan, would you like to ask your question?
Yeah, my question was, in fact, Ricardo, of let's say, how many instruments do you have already commercialized, either directly through your institute or indirectly through partners? Because you talk a lot about that is possible, but I like to see or learn a little bit more what are really killer applications which can make it, so to speak, on short term directly into the industry.
So our device is available, and these 2 examples, the plastic identification or the caffeine content in coffee, is already available. And we're working on the next generation already, but the device is available already.
But I thought it was more intended for Ricardo. Sorry, Felix.
I'm sorry. My bad.
No problem.
No problem. Well, in our case, we have developed many solutions for a final user. Then there are some of these solutions have been implemented and installed in their facilities. But we are also cooperating with machinery manufacturers to transfer the technology to a machine manufacturer, because in that case, it's easy to transfer the innovation to the market. In this case, we have two collaborations here with Spanish manufacturers of machines in the field of bottle packaging and in the field of machinery for nuts.
Okay, thank you very much. And here on, I would like to move further with the presentations, and let's hear a bit more about food material, about the food contact material safety challenges and food processing from Marco. Marco, would you share your screen and share with us what do you think on the topic?
Let me know if you're able to see the screen.
We see the screen, but now we need to go to presentation mode.
Coming. Is it okay?
And go to another screen, a different display. Yes, this is perfect. Okay. Thank you. The floor is yours.
So first of all, I would like to introduce a little bit TÜV Rheinland. That is the company to whom I belong. It's a German company, is an international tech industry, has 20,000 employees, 2 million revenue, 2,000 million revenue, and over 500 offices worldwide. I belong to the product division about this, and specifically I'm leading the food contact material business. Now, what I would like to say is that our company use this type of technology as well, and we see these applied in several of our customers. And what I would like to do is, as explained by Elena, is to speak also what is around also photonics. So I will not speak specifically of photonics, but of what are the services that we can bring to this industry. In this sense, we have all the electrical safety part that include testing, EMC, CB scheme certification, testing of component, chemical testing in terms of REACH and ROCH, or other type of chemical legislation to what your machinery in overall needs then to comply if you want then to have it in the market. Additionally, what I would like to do is to focus also on another point that several times is not we can say covered, because when we have those type of machine are included in food processing line. And what we need to avoid between the different legislation is to have migration from this type of machinery or food processing line into the food directly. So migration is something that will happen with the time in any case, because any material will let migrate their component into the food. It depends from the time, the type of food, and the temperature that is applied, and the surface of the surface in contact, as well the type of food. In terms of legislation, if you want to go a little bit deeper, we have consumer product safety. Then we have divided into, one is the machine directive, and the other is the, we can say, legislation that is applied for who is manufacturing the product, that include also requirements like HACCP that are related to the food processing line in itself, definition. So with this also the part of the machine that will include the photonic technology. And linked to this, we have as well the food contact material safety legislation that is divided in the 1935 for Europe of 2023, but we have several types of additional legislation that are applied. What maybe several people don't know in the food processing line industry is that when they apply the CE marking for Europe or other type of marking on this type of machinery, they imply not only that it is electrically safe in terms of electrical safety or in terms of chemical for environment or mechanical or thermal, but it's also, they are also implying that all the food contact material that will go in contact with food will be basically compliant to the applicable legislation. And when we speak about legislation, the FCM legislation is quite tricky in this sense, because even if we eat and die more or less in the same way, the legislation is different country by country, okay? And the legislation, if you have a machine, you need to think to the component, then you need to think to the material for what the component is built, and the chemical that are inside. And for each of those chemicals, you need you have a positive list of ingredients that are different country by country, different type of testing that can be performed, and different type of declaration of conformity that needs to be provided. This is valid for the different type of country of distribution that you can see on the right, that have different legislation. In the last 25 years, we have got the bigger change in terms of legislation that we got worldwide, because during this period, because especially Asian country, but now also Europe, has renewed or has included the new legislation for those type of material. Now, in terms of service that we can bring to you, apart electrical safety, apart environmental safety, apart everything is related to electromagnetic compatibility, CB, etc. We have also specific food contact material services that are related to regulatory frame and regulatory management, to understand what are the applicable legislation that apply to your product when it's entering a specific market. Compliance by design services, and this is also applicable to electrical safety. So you can come with a prototype and we can verify that since from the design, the risk assessment of the same is positive and you don't have issue, or in terms also of hygienic design of the same, we can perform audit in your facility. We can support you in the assessment of your design and process HACCP, that is a kind of FMEA, but applicable for food specifically, for what that your product needs to comply with as well. We have microbiological laboratory, hygienic product certification that you can bring on it. Declaration of conformity management services that are the services in way that that will help you to build up the declaration to support the selling of your product in the specific market, going back to upstream to the raw material, to each component, and then to the final machine. And then at the end, we have as well testing. That means chemical testing, targeted or untargeted, and additional training service and certification. Between the certification that is more useful, we can say, for the food processing line, we have EHEDG for what we are certified, that has also a hygienic design rule related to this type of product. We can support you also with a specific Chinese certification that is recognized in the market, that is CQC, because our test reports are recognized as well by this entity. So in short, if you have a product that you want to bring in the market, you don't need to speak Chinese, Brazilian, or that is Portuguese, or Spanish, or another language, because we will do it for you. We will select the right partner to perform the testing if we don't have the specific accreditation in the specific market, and this will allow you also to have a shorter time to market in this sense. We have developed a really huge bench number of services that are all around what you are discussing today, that can support you in the research and development step in terms of compliance by design to select the right material, to the finished product testing of the product. We have a bench of different people that can support you worldwide, that are included in my presentation, that we will share with you together with the landing page of our site. So this was a little bit the short introduction I wanted to do with you. So thank you very much.
Thank you very much, Marco. It is the first ever presentation by TUV at any of our events. So officially welcome to the EPIC family. It is for us fantastic to have an entry point into TUV, because at the end of the day, you're doing the validation of almost any production, and having all the photonic technologies help you doing the validation is priceless. We have a question for you. The question is coming from my friend, Paul Spoelstra from Marel. Paul, what's on your mind? Oh, we have you muted, which is perhaps the sentence of the year.
Muted. Yeah. The question is, for example, around the approval of QNIL, a copper nickel aluminum alloy. The question for TUV is in relation to organoleptic behavior, for example, what the complexity and timeline is for such an approval nowadays.
The approval, as explained, is depends on the market where you want to go. Because the material that is in contact with the food is, we can say, defined in some country based on a defined positive list. So what is important is to identify, first of all, if there is any restriction related to the specific material. So if this is listed, if it's a plastic material. In this case, it's more a metallic material. So we need to look more on the metal part of the legislation that is different country by country. And what in some countries like Italy, we have also positive list for metallic material, of France in terms of minimum content, or in China in terms of release. The testing in itself is not so long. You need to keep in consideration that you will have a repeated use, because your product will be constantly in use with the food. And therefore, normally this, if you say that the product is in contact, I don't know, 1 day per 24 hours in contact with the food, then you need to do 3 times the 24-hour test simulation. And you get, at the end, in 1 week, you get out a test report for it. The problem is not really in the testing of the product, but in the qualification of the different material when those are not listed in the specific list.
Yeah, thank you very much, Marco. We have a question in YouTube. Going all the way to Campden BRI, going all the way to Martin. Martin, listen to this. We have a question from Jonathan Marks, CEO of Critical Distance. He's wondering, are there photonic technologies that could be used in supermarket apps to help people with allergens to avoid certain foodstuff and spices? And he says, I remember that Albertine, which is a Dutch chain of supermarkets, I Googled that, did some trials.
I don't know of them, but it would be lovely if anyone in this meeting has suggestions. I mean, we do a lot of allergen testing and a number of methods that we use, but they're largely laboratory methods, some more rapid than others. But yeah, I mean, even before it becomes available to the consumer, something that you could use in a food factory to say, have I cleaned my production line? Is it free of allergens? I've changed over from one product to another. There's a need there. So a meeting like this is great. If anyone's got
that's great. So we have now the company taking the...
and we're happy to sort of help out with evaluating it and trying against the reference methods.
Challenge accepted, Martin. Let's go to the supply chain. Let's go to Xenorics. Robert is here from Xenorics, right?
Yeah.
So Robert, you are trying to miniaturize as much as possible integrated sensors to be used in the consumer, right? To actually bring expensive hyperspectral imaging all the way to consumer. When you see a challenge like this, apps in consumer side to detect allergens, what's on your mind?
That's definitely a tough one, that's for sure. My take on this would be that I would say we're not there yet. You know, that would be my take on this question. I would not exclude the option that photonics technology can develop in this regard and can go all the way. But right now it's really challenging because you have to keep in mind, usually when we talk about allergens, the concentration level of these substances are really, really slow in whether we talk about gluten or lactose. You know, lactose is a little bit different because that's rather high, but a lot of things, it's really tricky. And then you have the issue, it's a tricky field to move into because some people are very, very seriously allergic to certain substances when we think of peanuts or so. And I don't think this is the low-hanging fruit for the industry, but it's not something that is, from my point of view, impossible in the long run. But
in the last 5 years, we have seen a lot of research projects, some of them from Wageningen in the Netherlands. I think we have somebody in the room from there. Others also from Campden BRI, also from Eindhoven area. I really would like to call now for everyone. If you have a solution for this, there is a real market need. So tell us and we will introduce you to the right partners. And with this, I would like to move on because today really is not only important to finish in time, but also to have the whole picture. And we cannot build the whole picture without the next presentation. For our next speaker is coming all the way from the Netherlands. It's coming from Wageningen, who has positioned themselves as a key place in the supply chain to connecting end users to new photonic technologies in agriculture, but also in the food and beverage process. Puneet Mishra is here with us all the way from Wageningen in the beautiful country with windmills and tulips, the Netherlands, the floor, and the attention of everyone goes to you.
Hi, I think you can hear me better.
Loud and clear.
Yeah, that's fine. So my name is Puneet Mishra and I am from Wageningen Food and Biogas Research. I'm originally from India, and but most of my time spent in Europe. I studied different parts of Europe like Spain, France, Belgium, Germany, and I studied multiple universities. I had a PhD as well after that. And in this presentation, what I would like to explain you is what is Wageningen and what we are doing in the field of food and biogas research. And I expect this is our first presentation in this kind of meeting with EPIC. And I suppose I will give you a brief explanation about most of the things. So Wageningen University and Research, it's two organizations, but they are merged together. So one is university and one is research. So we have the core research, like the completely new stuff being developed at the university part of Wageningen. And then we apply this very new research directly to the customer level, or we do it practical applications of this new knowledge that we generate in university. Based on the statistics from multiple years, we stand #1 still in the field of agri-food research. It's a university for the world. We work for the whole world. We are not only based for Dutch consumers or Dutch audience, but we have a very broad international so wide grip on this topic of agri-food. And especially our students, they come from all around the world, especially more than 100 nations. And not only students, but people like me who work for Wageningen. It's full of international people. So, and the most interesting thing about Wageningen is it optimized agriculture and agri-food chain, because this is a screenshot that I took from this National Geographic magazine, where they highlighted the main feature of Netherlands, which is being such a small country and feeding the whole world. So Netherlands actually export to the whole world different kinds of crops and agri-food material, and which stands very far in the scale compared to other countries of even 10 size bigger than Netherlands. So especially even my country, India, which is very big, it doesn't even match Netherlands export. But who I am? So I have a PhD in process analytical chemistry, which is a domain of pharmaceuticals and chemical engineering. So I studied that in Center for Process Analytics and Control Technologies in Glasgow. And I was working mainly in the pharmaceutical processes like crystallization optimization and real-time monitoring of stuff. And then I moved to Wageningen to my job, where I apply all these things that I learned in PAT in pharmaceutical domain and try to implement that in agri-food and also food industrial domain, where we try to monitor processes and optimize this process. There have been, I have been working a lot in the scientific domain as well, and we have developed completely new algorithms to do chemometrics, as well as data fusion, as well as deep learning. Some of the people in this meeting are aware of some of the developments that we are doing a long time, but some of you are very new in this domain as well, I can expect. Yeah. So for Wageningen, the scope of photonics is not really only limited to processed food or food processing, but we are actually distributed along the whole chain from production, even before production, just with seedling stages. We are involved in that, and we deal with the seeding like robotics as well, where we deploy different kind of sensing technologies to actually support the robots for doing actuations and this kind of motions and decision making. We do lots of solutions also for planting of agro materials, which is dealing with the cuttings and having robots that they actually plant something on a pot for you. And there is also a lot of stuff that we do for applying photonic technologies to monitor plants, because that's a big necessity in the domain of agri-food domain. We are very active also in harvesting of fresh produce in the fields. Then we are very active as well in food processing, so developing new processes and developing new kind of applications, sensing technologies for doing, especially nowadays, like the 3D printing. We are exploring a lot of photonic technologies to actually measure the structure of 3D printed food. We also are active in bin picking, and dealing with handling of food of any type. So we are also very active nowadays in food wastage recovery, and also in dealing with circular food chains. So we are employing different kinds of photonic technologies. They range from spectroscopy to simple camera, and we use them. So what we offer normally is we are not a photonic manufacturer. What we offer is a scientific base, because we have a very good research base at Wageningen, and facilities as well. They range from fresh fruit analysis to food manufacturing. So we also have a lot of multinational companies in Wageningen, not only in Wageningen University, but like big companies like Unilever, Friesland Campina. They all are based in Wageningen, just next door to us. So, and we work together with them a lot on this topic. But we also facilitate we facilitate the fast track of transition. That is normally if you have developed a new technology and you are trying to sort out the applications for it. We normally have lots of customers already looking for something like that. So we normally try to do matchmaking, and we help in that kind of stuff as well. The ways to engage are, we do independent contract bilateral researchers. We also provide consultancy and courses, and we also support like different kind of projects like PPP and European level projects. So we also provide specific products. Especially an example I can present you here is if you are a company that manufactures a new sensor, and it's a very new sensor, and you like to test this sensor for some kind of fruit, maybe for a strawberry. So definitely you need to verify that the sensor is working perfectly in this different kind of fruits. And in that case, you have to answer many questions. One thing is to calibrate, how to calibrate the sensor and what kind of properties it can predict. You have to do this kind of search for it. Most of the time you know it somehow, but still you have to validate it with the reference measurements. And you also have to check how your sensor is different from the currently available state-of-the-art sensors in the market. So we provide solutions for that. One of them is this multi-sensor comparison approach that we do. And in that case, we have real-world facilities where we can do all kind of validation experiments for your products and give you data as well for doing any further calibrations.
Thank you so very much. Yeah. I see that you have a slide here, and it comes together with my question. So we have a full supply chain of photonics technologies here. Wageningen has a lot of ideas and a lot of experience working with photonics technologies. So what the supply chain can do for you, how we can help Wageningen University to do even better research and development?
Yeah, so I think there are two parts of it. So as Wageningen University and research are two parts. So I would say there's one of them is a business part, where if you are looking for your sensors to be ready for the market, or you like to validate them on the foods and food products, then you can go through the business opportunity part. But if you are looking towards for new future concepts of food, which are also active in Wageningen, like 3D food printing, like replacing meat products with meat replacer, like plant-based proteins, and also circular food chains and waste recovery, then in that case, you can combine maybe through more scientific approach. And yeah, so there are multiple ways. It's a business base or it's the scientific base. So both of them are available.
And do you also have any particular need in some particular photonics technologies? So maybe some light sources or some camera and sensors. We have a lot of those today in the room.
Yeah, so I think I can explain you two cases. The first case is very interesting for us. Is we are searching for like a light source for hyperspectral imaging cameras, but there has to be LED light source because we are tired of using halogen light source because they need to stabilize. They have all this problem. They always lead to heating up of the system. And we are trying to find a solution with LED light source, which can actually replace the halogen ones for especially for NIR spectroscopy imaging applications until 1000 nanometer. And if any company offers that kind of solution, we are very happy. We are very excited to explore that with you.
Mm.
And,
Puneet, or let's say, do you think it's really possible? Because most of the LED light sources are somewhere, say, phosphorus based, and they have a very peaked spectrum even after the phosphorus. So if you really want to do hyperspectral, you normally expect to have a very smooth emission spectrum from your light sources.
Yeah. Yeah, so we are currently, we are engaged with a company currently, I think they call Epilux or something like that. And we are testing their lights and they are actually providing us very nice spectrum until 900 nanometer. But just after 900 nanometer where you have the water band, it's giving some noisy signal. So we are still in the search if we can find something better. But otherwise we combine halogen with LED or something like that. So.
Okay, so as we go more into imagers, light solutions, cameras, and sensors, we are moving to Teledyne, DALSA, and Mike, who will be telling us about the solutions they are developing. Mike, how are you doing? Thank you for being with us today. And please, the attention of everyone is yours.
Thank you for having me, and thank you to everybody who's presented so far. A lot of very informative presentations, and I've been very busy taking a few pages of notes already. So this has been very informative for me so far. So I am from Teledyne DALSA, a part of the Teledyne Digital Imaging Group. We are a global player in the photonics and machine vision market, and we've been involved in products for the food and beverage industry for over 20 years. So we have a broad portfolio of products for various types of applications, including line scan sensors, normal 2D cameras, 3D sensors, thermal cameras, software, and so on and so on and so on. But again, with that 20 years of experience, we have had some exposure to many of the applications that we've talked about today. So, you know, if you're looking for a camera or an imaging product, maybe we have the right one for you. I'll start with the area scan cameras. These are, you know, cameras as you're normally aware of them. And with our cameras, we can facilitate setups with multiple cameras for whole fruit or vegetable inspection in lane sorters. So this is, you know, when you need to get all of the different angles. On the beverage side, where our cameras are used for glass bottle inspection, we're also seeing them adopted in packaging applications where we need to look at seals or caps or labels. We have a number of built-in functions in these cameras to capture information from different wavelengths in rapid sequences at high speed. We can differentiate colors in a single pass with one camera. We have near IR capability. And again, a lot of that was born from requirements in the food industry, how they needed to see more and more detail or be able to differentiate products better and better. On line scan products, so if there's motion and it's high speed and you need high resolution, perhaps a line scan product is the right fit. And we of course have these available in color and with included near IR performance. And so a lot of customers, similar applications to what we've talked about today, they need to see foreign materials like glass or silica gel that gets blended in with the product stream, or just looking at quality markers. So in food sorting, in packaging, in printed labels, again, presence, absence, shape, color, defects, foreign contaminants. so on and so on. With a camera like this, you gain additional information about objects, and you can better differentiate similar colors in a single pass with one camera. New this year is our first shortwave infrared camera, the Lineosphere, and I think I heard a number of different challenges that some companies are facing with being able to detect moisture or differentiating materials with a similar color. In some cases, there's so much information that we need to capture, and we need a hyperspectral camera. In other cases, a shortwave infrared camera can do that. One of the highlights of the shortwave infrared is, of course, its ability to detect moisture. So we can see indicators of bruising or spoilage or leaks in packaging. Leaks in packaging is a really important one. We can still, better detect foreign objects, and this, of course, helps customers of ours that do things like food sorting increase yields, reduce waste, which was something that the gentleman from PepsiCo was talking about, the need to reduce waste and identify that waste early on. Overall, the goal with our products is to help our customers improve their product quality. Because this is the Photonics for food and beverage industry presentation, I want to touch a bit on food sorting. So the Lineosphere is, of course, applicable here, but as are many of our products. And again, I talked about moisture content, bruising, foreign objects. You can see here some images where on the right-hand side, the coffee beans and raisins. I know you probably don't usually have this problem where there's raisins in your coffee, but here we have, a good example of something that the color is very similar and the shape is quite similar as well, especially at high speed. In the sphere, we can see that there's a clear difference between the coffee and the raisin. 3D laser profiling. This was an interesting one for me, but I guess in the age of social media, if your product is not consistent, somebody might look at it and say, oh, this cookie is, they screwed up my cookie, and look at the weird shape and everything. And it goes on Twitter and it goes on Facebook and Instagram. We, of course, consumers want more and more consistency. So with something like a laser profile, like the Z-Track for volumetric measurements or shape or things like that, we can help our customers improve that consistency. I only have 6 minutes. I think I'm on time. That concludes my presentation. I can briefly mention some challenges that we face. So each customer has specific needs, and often those are all very different. We get a lot of questions about which product would be best for imaging some sort of interesting feature. And if we've never seen that challenge before, really the only solution is to try and help the customer as best we can to test those applications. And maybe we have to start with hyperspectral and narrow down the most interesting bands, but hopefully we can help customers figure that out.
Thank you very much, Mike. I'm a huge fan. I'm a huge fan of the whole Teledyne group, and having Teledyne DALSA today was really interesting for us. Of course, Mike, remember that we're still working on getting your form to have you in the list. But before I saw this slide, which of course bring me a lot of interest here. You have been in touch with many end users. You are one of the market leaders. When it comes to the first question that we ask in the meeting, what processes you are aiming to do real time and what processes are not to be done real time? Do you have extra information on this for these particular examples that you list here?
Mm-hmm. I think in many cases for our products, because of our capability of high speed, most of the work that we've done is in real time. And that's most of the requests that we get. I think there are certainly applications where that isn't necessary, but at least the exposure that I have is mostly real time. And faster is what we're asked for a lot.
We have a question from Art Photonics all the way from Berlin. My good friend Slava, what's on your mind?
Just one question, Mike. Everything is great. Teledyne cameras are excellent tool, to see product surface. What's about, let's say, inline monitoring of, let's say, liquids or what else, when you should see something under the surface, because even package is not always transparent. So we are able to provide fiber optic bundles or probes which can be coupled to your cameras and can look inside. Then it can be kind of, I don't know, octopus.
Terahertz imaging?
Sorry?
Terahertz imaging, maybe that can look to some extent beneath the surface, especially also for moisture containing articles.
Yeah, no, it's important when you have a silos building, which is multi-tone stuff. You could not go in every corner of this kind of building and control moisture. You need some kind of distributed stuff inside this grain volume, and monitor in three-dimensional picture. So that's why cameras are always good, but you see only the surface. So the question how to go inside. And with our fiber optic probes, we are really keen with Marel, with Teledyne, really to go inside. Yeah. Okay,
because you mentioned terahertz imaging, so you know that I have everything that I want to make a business today. Mauro from Lighted, do you have an answer to Paul about terahertz imaging for a particular application in this industry?
Well, first of all, hello to everybody. I'm Mauro from Lighted in France.
You look fantastic, but we cannot hear you. Can you speak a bit louder?
Oh, really? Okay. Is it better now?
Yes.
Okay, sorry for that. So, hello to everyone. Yes, the point is that we want to propose terahertz imaging. So terahertz could be a solution to have.
Actually, no, we cannot hear you. Sorry, you need to try to speak a bit. Oh, that's the worst advice I ever given to anyone. So
I'm alone.
Okay, if you're alone, take the mask off and let's hear you properly.
Yes, it's just the habit of having the mask all day long. So.
Which is something that everybody should do. Wear a mask and wash your hands, please. Yes.
So it should be better now.
Better.
Okay, but not optimal. Yes. Well, yes. The idea of Lighted is that still no.
No, let's try to fix the microphone, play with the settings, and I come back to you in the next Q&A, because once again, I really want to finish on time. And the next presentation is always, in any life science meeting that we organize, the next presentation is the one that gets the most interest. We are going to go to BaseSpec. We are going to go to William Young, the principal technologist and co-founder of BaseSpec. Thank you very much, William, for being with us today. The floor and the attention of everyone goes to you. By the way, first, the key question. It is 4:36 in the Netherlands. What time is it over there?
It's about 7:36 in the morning.
Good morning, William. The floor is yours.
Good morning, all the way from California. Here, for the people who don't know BaseSpec, here's one page of propaganda. We are based in the name calls itself is BaseSpec's Bay, San Francisco Bay Area. We've been here for 20 years. We manufacture, we do everything here in Southside, California. The name of spec is spectroscopy. It's in the name. We have that DNA in spectroscopy since the beginning. And the first product we did 20 years ago is not relevant to today's topic, but I thought I should bring that out so people know how we get into spectroscopy. Look at the second page. It's very funny. It's very interesting this morning. Everybody every previous speakers mentioned about Raman, fluorescence, shortwave AR, near AR, all the applications. But BaseSpec has been doing that for 20 years, making all of those instruments mentioned this morning. It's very interesting. Also, don't forget hyperspectral imagers. We make many different type, very tiny, small hyperspectral imagers. Our customers use the imagers in-house, also outside by a UAV or handheld. If you're looking at on the right-hand side, the bottom corner is related to this morning's topic. It's about ultra miniature, very small spectrometers in the longer wavelengths near error range. We call it short wave error. They are made with our volume grating technology, and it can cover the wavelength range all the way to 2,500 nanometers. So there's no clear boundary, but other people would say when it's beyond the 2,500 nanometer, it will be called mid-error. We don't have time to talk about the physics behind it, why you want a little bit longer wavelengths than the near error, but the idea is it will collect, it covers the near error, but also collect more information than the near error. This is not really new technology because we've been making this similar spectrometers for many years. There's one participant of this meeting, Jens, I believe Jan, asking about, there's one person asked how many units of this shipped. The similar spectrometers, I can tell you in the sphere range, we have made all different forms. It's been 45,000 spectrometers have been deployed in the field. Of course, probably 35,000 of those went to the internet, went to the fiber optic network. So we just gave you an idea that the capability here, that this is not a lab idea, a prototype. This has been made so many times over. Now, these devices are all made through the Bluetooth connect to the smartphone, whether it's an iPhone, which is 10 kilometers away from us, or an Android phone. So these are very easy to use. And some person also mentioned about connecting to cloud. This is all connected to the cloud already. So give you a quick idea that about the apps we made, and we measured some food here. If you look, there's cheese, there's lettuce, there's orange, there's tea. So on the right-hand side, you will see, we call it a bridge, right? Make it easy, right? So measurement, it could be very easy. You don't need to worry too much about the training. We don't have to have a PhD to operate it. It doesn't have to be more than probably 20 minutes training. You'll be able to use it. You point, you touch the screen, just like you play with your smartphone. Well, this slide shows you an example on measuring cheese. Been mentioned many times by the previous speakers. Again, this is connected to the cloud. You can do chemometrics. You can do data gathering. You can do calibration if you want. You can search for a library if necessary. If you pay attention to the screen, to the snapshot there, there's a red curve, red spectrum, and the white spectrum. They kind of overlap each other. The red, in fact, is the library. The user can build his or her own library on the phone very easily by touching few buttons. You can call whatever it is, if you like. Some other people mentioned about measuring strawberry. It's already been done by one customer using this device. Next one, I think my time's going to be run out very quickly. A lot of other speakers mentioned about measuring whatever they want to measure. Of course, when you're doing near error sphere spectroscopy, you can detect, you can make analysis of many different parameters, different chemistries. I want to point out one thing is the device has been made so tiny, so small. Of course, it look like a key fob. It look like very it can be made into a watch, wristwatch. Okay, these are for the spy agencies. I don't want to mention the name, but it's been done. I think my time is up.
Yes, that was truly fantastic, William. You did again a great job. Thank you very much for this. And now let's try to find opportunities for cooperation with the rest of the members. Let's do that because we did that great the last time you presented about a year ago. Let's show you this slide. This slide is great, and you have managed to do fantastic thing. But this is a meeting for the photonics companies. Can you share with us some challenges that you may have in the packaging of the detectors, or new wavelengths that you try to reach, or new integration solutions that you want to get? Could you share with us a couple of challenges on that respect?
Well, the one challenge is to make the device small is easy, but to maintain spectral resolution, which is one of the key parameters of any instrument, it's against making the small. So you have to balance that. That's a major challenge. You need to balance the performance of the device, but at the same time, you want to make it small. For example, I mentioned about spy agencies. They don't necessarily understand that smaller is against the sensitivity, against the resolution. So you need to make it really, really balanced.
A challenge for all the companies who are trying to integrate detectors and different kind of sensors into an integrated solution. They want to go all the way to 2.5 micrometers, so there is clear room for cooperation. Thank you very much, William. I want to address 2 points. The first one, I want to go to photon lines. Eric, the reason I want to go to you is because you are a distributor with added value, and that has been very clear over the years. You go to the end users and try to solve their problems. How are you approaching from France? How are you approaching this particular market?
Hello, Jose. Hello, everybody. Yes, we are in a very specific situation in photon lines as an added value distribution company. What is interesting here is that we are also based in Brittany. And Brittany is a fantastic part of the France, for food industries and for agriculture. So what we are doing now is we try, to go on the field, because there are many small and medium-sized food company which needs, to understand what are photonics technologies. So part of our job is really, to visit those customers and to bring them, those technologies and try to make them to understand what we can really do with those technologies and to make them, easy and comfortable enough to, in the future, invest in this kind of technologies. For instance, we develop our own platform software. With our platform software, we control different kind of technologies, camera, spectrometer, hyperspectral camera. We also control different kind of illuminations, LEDs, lasers, whatever. And we also have the possibilities, to provide some first data processing, because we speak about data acquisitions, we speak about speed, but the most intelligent sensor we have also collect a lot of data that we have to process. So we
have been amazed by working with Eric in the last years. If you are looking, for example, William, if you are looking for a distributor in France who knows the market extremely well, that's great. But also for the end users today, if you want to understand how all these camera solutions fit in your particular challenges, Eric is the person to go. Thank you, Eric, for being here. But I want to go back to the terahertz because I love that. And Paul challenged before my friend Mauro from Lighted. Lighted is a new startup in the terahertz sources business. Mauro, tell us now, because I think we can hear you.
Is it better now? Is
Much
it better now?
Yes.
Okay, yes. Okay, so again, hello to everyone. So yes, actually, we are working a lot in the domain of terahertz imaging. We are developing some systems in the sub-terahertz regime, so from the 10th of gigahertz to the hundreds of gigahertz, and also in the terahertz regime, so from 1 to, let's say, 5 terahertz. Not only imaging with terahertz, but also terahertz spectroscopy with tunable sources. So Just to go straight to the point of the EPIC questions, I would say that we are very interested in this kind of market because we can provide actually with Ernst some more penetration and non-destructive imaging and analysis. What we need actually, what we need from you is actually some feedback and collaboration about pinpoint, let's say, the specs that you need.
We had a meeting on pharma industries, and there were some questions about looking at the pills through the package, and that was great. Today is the same for the end users. Exactly. This guy can look through anything. Water absorbs terahertz, but nothing else does. So it is a really, really great problem solver. So I hope in the one-on-one meetings after the meeting, we can do something. And with this, I go to Berlin. I go to Slava Artyushenko, Art Photonics. In the life science business, you always have great contributions. Tell us how you address the food and beverage market. The floor and the attention of everyone goes to Slava, goes to Art Photonics. We have you muted, I believe, or at least we can't hear you. Yes, we have you muted. You need to unmute. Yes, I think now we can hear you well.
Okay, great.
Yes.
Hope my screen is visible.
Crystal clear.
Yeah, great. Just to start from evident statement, you know, when we see something nice like this chicken on the screen, great advertisement of EPIC, question, you know, if it will be as tasty as this picture, because everything which was discussed mostly today was about, let's say, analysis of the food from the surface. And we are fiber optic guys, and we always would like to go inside and try the test of the wine, milk, or what else, you know. So we are, you know, that in the field of spectroscopy, there are many methods, different spectral ranges, and mid-infrared is one of the most informative range where the most of laboratories are doing analysis if we compare with other methods. And of course, to go inside the bottle, you couldn't always go only through the glass. You should really go inside. Then it's good to have a chance to go in and test or analyze molecular composition. So that's why I will mostly be focused on kind of, let's say, cases where without fibers, test of the food or beverages is simply impossible. So you're probably familiar that in general, there are several methods of spectroscopy which can be used in visible range, which can be used in near-infrared, and then mid-infrared is the most informative. So that's why it's so information rich. We simply have all the fibers from UV up to 16, 17 microns in hands. We produce part of the fibers like this unique fiber for mid-infrared, and we make any kind of probes. And when we try to select the best solution, the best fiber optic probe or the best spectroscopy method, we have a system in laboratory when we have Raman, FTIR, fluorescence, and infrared on the table. So then we can go in any process and control inline. So we are mostly doing, our main focus is inline spectroscopy to see what kind of changes. You make your soup, you should know when it's ready. When you try your milk, you should know if it's fresh or it's already too old and maybe even dangerous. So that's why when we look for many methods used in food analysis and beverages analysis up to now, it's still kind of bench spectrometers. So you should bring a sample, put it on spectrometer. You should put milk in and let's say probe inside it. Sometimes you can have a small spectrometer, like it was nice presentation from BasePack. Yes, when it's like a palm size, you can approach, but again, you will measure only on the surface. So that's why the new generation of process spectrometers is really not only the spectrometer, but it's also fiber optic probe, well connected. to enable monitoring of, for example, milk composition inline. Unfortunately, I didn't manage, to invite FOSS to this great meeting, but I share some slides, from their website. We are good partners, and you can see how milk, which is one of the major products for our life, is controlled when we, for example, do mid-infrared spectroscopy and see how dry milk is dissolved. Then, you can control when it's completely dissolved. It can be done in near-infrared as well. But in mid-infrared, where the information about glucose, lactose, fat, what else, must be measured as fast as possible. For example, great progress was made by FOSS from the, classic way to measure 2 samples per hour to kind of, let's say, milk stream device, which measure the stream of milk every 7 seconds. So in result, of course, it's much better quality control, and in result, it's possible to make also better profit from the business in industry. As I mentioned, we have any type of fibers which covers the range from UV up to mid-infrared. And when we see that in infrared, you really must control something in liquid, here is ethanol spectra, and you can control concentration of ethanol in water. When it's powders like sugar, starch, flour, measurements of moisture is extremely important. Who wants to buy a kilo of sugar where it will be too much water, or it will be problems? Any bakery would like to have really starch without moisture or flour. So we produce some kind of special probes which control concentration of moisture in process, not only moisture, but other parameters as well, in pharma industry, in food industry, and so on. Up to 9 windows at this kind of side looking probe. Spectrometers are still relatively expensive, so spectrometer can cost from 10 to 20,000. We decided that for some simple applications like moisture control, it's enough to select several absorption bands for water and references and replace the whole spectrometer by moisture sensor. So you use only 4 LED and 1 photodiode. In result, you can simply measure moisture with a precision of, let's say, 0.1%. And you can do it with any type of fiber optic probes. Not only on the surface, you can go deep inside and measure. Surprisingly for us, it was also found that we can measure, let's say, water in vodka or vodka in water, with this kind of other type of the probe. In general, advantage of this sensor, it's a device with a simple software inside, with a data transfer, which can be by cable or Wi-Fi to cloud. Then you can really distribute hundreds of sensors or more through the huge silos building and control moisture in any point to know what happens. Here, again, milk. Milk is one of the main liquid. Let's say whiskey, because we have very interesting results for whiskey, but you can really control it by different methods: near-infrared reflection, fluorescence, absorption, and in general, this is even a type of chocolate, which is very different. So quality control is easy to do in mid-infrared. I think what is coming because of COVID and pandemic in the world, we already developed some stuff which can be used for medical applications. And when you use quantum cascade lasers, you can control gas phase. That's why when you do your soup, you simply try to test its aroma. Or when you try with your good sommelier, type of wine, aroma comes first. And it's possible to change it from, human factor to quantitative analysis using quantum cascade laser with pure fiber nodes. Oh, sorry. Just a moment. So my last slides. just to mention that in general, I think the future will be with a lot of fiber optic probes which are distributed. Either it's sugar plant or it's, let's say, bakery, and it can be used not only for industry, not only for food processing. You see that in general, biophotonics now attracts a lot of, let's say, investors in this field, especially now when we sit at home and would like to get very good and very fresh food. So that's why I think this webinar today, seminar, is really more than for industrial use. It's even for every consumer. So that's why here, just to end by classic question, you know, what we would like to hear from the partners at EPIC, you know, look, if there is some kind of, let's say, end user here and, you know, system integrator from the right, we are somewhere in between. So we are doing fiber optic bridges, and we are very interested to hear about problems from the end user and have partners for the complete sensor, complete system creation, development for end user. So welcome to collaboration.
And you're doing really great job developing the fiber sensors and solutions and integrating more than one solution altogether. Thank you so much for that. And I keep having the question in my head since you mentioned at the beginning the fiber measuring the soup. So when my pan will be telling me about the ingredients and how to actually cook my soup, how soon the fiber sensors will be integrated in the whole cooking solution?
Yeah, we are after 22 years being in B2B business, you know, providing any kind of fiber optic solutions for our partners and end users. We are one of the major suppliers to big analytical companies like Thermo, ABB, Bruker, Meta Toledo, and so on. But it's still expensive instruments. That's why I believe that, let's say, something like this tiny, it's smaller than a palm size, detectors which will help, let's say, to control parameter, customized parameter. It will be customized sensors. And it will be really kind of, how to say, part of Internet of Things. Because today, you know, there are already some software when you can put application in your camera, go to a restaurant and try to control how many calories are in your food. It's nice, but nevertheless, you measure surface. You know, that's why we always try to go in, and we, for example, can easily with our sensor to distinguish, let's say, single malt whiskey from fake whiskey, because on the market, 70% of whiskey is fake. You know, it's, and you should measure caramel A and caramel B, not only alcohol. So, and you can do it, but not by...
There are so many measurements to, so many things to take care of and so many parameters to look into. And there are so many technologies developed. We also have together with us today, Heinrich from Fraunhofer AMPMS. Would you please tell us a little bit of what are you working on, and maybe share with us the developments from Fraunhofer?
Oh, in general, we have a lot of partners, and for you mean Fraunhofer? It's another presentation, I think.
Yeah, you can.
They have also a lot of work in. Yes, we can see your slide.
Okay.
How about you share with us also what is it there?
Yes, hello. This is Heinrich Rüger from Fraunhofer IPMS. We have heard a lot about cost and size of near-infrared spectrometers, and on this slide you can see our work during the last 20 years, how to integrate spectrometers to a very small size, implementing a technology to realize gratings on MEMS devices, the chip, and then new approaches to integrate the system which are capable to produce spectrometers in very high volume. So instead of assembling all the components in a 3D body, the new approach is to place the components on a mostly planar substrate and then fold the body and generate the optical path inside. This might help to reduce the size, to merge with the requirements for a mobile phone, directly integrated, but nevertheless, it will also be capable to get very robust spectrometers for applications in the food processing industry and along the entire food chain from field to fork, as it is called today. So for technology, device realization, system design and integration, and application, IPMS can be your partner.
Thank you so very much for so miniaturized near-infrared spectral analyzer, fiber optic sensors, they all can offer a lot of solutions. But moving to the end and final presentation of this meeting, we are moving to a very exotic application of photonics technologies for food industry. We have today with us co-founder and CEO from Natural Machines, Emilio. And Emilio, please tell us about how we can maybe print this time the Christmas tree, not only decorate on standing on the floor, but also on our dining table, on our very plates.
Sure. Let me share a short presentation, and you will see what we are doing and what that may mean. Can you see? No. Okay.
It is
great.
coming.
Yeah. Okay.
Yes.
So, yeah, I guess you can say it now. We are a company that is doing kitchen appliances and using technologies that till now were using in our environments. So we are using 3D food printing, we are using artificial vision, augmented reality, and some other technologies that are related to photonics, and I will get deeper into that to help us bring the food factory into our home. So essentially what we are looking forward to do is to recreate, if you think of Star Trek Replicator or other movies, a device that can provide you the food with a single touch of a button. It doesn't mean that you have to use special ingredients. You can use fresh ingredients. You can use your own food. It's not forcing you to change your habits. So we already have a product in the market. We are working mainly with professional customers. And what we are helping is to bring the factory to the consumption point. This way you can save a lot of packaging. You can save a lot of food waste because you only produce what you're going to consume. You can get into more personalization. So you are not tied to the shelf space in the supermarket. So essentially you are becoming your own food manufacturer. And this is helping you get a better eating experience, getting a more tailored nutrition, but also helping reduce the food waste both in production and in consumption. So as mentioned, the process we follow is very similar to what you will find in a factory that is producing cookies or pizzas or any other food you may find in the supermarket. And the only thing is that we adapted this technology to fit in a kitchen factor. And it happens to be called 3D printing. But at the end of the day, it's the same technology. And the message for you would be like, if you think that printing food is weird, this is what happens inside a factory. The only thing is that nobody called that food printing because there was other names that were better fitted to what they are doing in the factory. But at the end of the day, it's the same process and it's the same way of producing food. The only thing is that you can tailor that to what you need or what you want. So the way you put ingredients inside the device is using these kind of containers, and that allows you to use a range of textures that go from liquid to foods that have solid chunks, like maybe couscous or mincemeat or whatever you may think of. You can warm the ingredient to make it fluid, like for example in chocolate or icing, or you can use room temperature. And depending on environment, you want to keep the ingredient warm over 60 degrees to avoid the creation of any bacteria during the process and keep it safe for the consumer. So the applications you would find for this technology are like broad. At the end of the day, I think this is a tool used in the kitchen. So you use a pan, you use a microwave oven, and you use them in different ways. So it's not a single application. But of course, the number of things you can achieve and get from it are very different. So for example, we are combining the printing capability with artificial vision and artificial or augmented reality. So you can do decoration. So we can detect if you put a cookie or a cake and center a decoration on top of it. You can see how it's going to be looking like by positioning what you want to print on top of this object, and see the real object with the what would be the decoration. So this is something that is helping a lot, reducing the human contact with food, and is getting very fast return on investment for the users that get this application. But we are also working in hospitals and nursing homes for elderly people or people with cancer. So you can recreate foods, but with the right texture for them, for people with dysphagia. We are working also in some cases with anorexia and some other diseases. And we are also working with plant-based substitutes of meat and fish. So in this case, you would see what seems a tuna steak, but it's not tuna. It's made of mycoproteins, essentially mushrooms. So you can recreate the taste, the look, and the chunkiness of it with the printing technology. What we are doing now, and this comes probably better into the discussion today, is we are using, we have a new device that is also cooking, not only printing. So you can get in a single step your food from ingredient to final dish. And we are using laser to cook. Laser is a technology that allows us to use only a portion of the energy used in an oven, and allows us to control the temperature at which we are cooking. And we cook at a very low temperature, but enough to kill all the bacteria. And that means that we keep all the moisture inside. It's tastier. We did consumer taste tests, and they prefer that technology compared to a pan or a grill. And because of this cooking temperature as well, we avoid the creation of benzopyrene and acrylamides, which cause cancer. All these black substances you get when you cook, those are not really good for your health. So all in all, we are trying to get people healthier eating, personalized experience, and also helping the economy or the cooking of our food to become more friendly with the environment, reducing food waste and reducing energy consumption. And of course, because of the way we cook, we don't need any water or oil to cook. So that means also we can help a bit saving energy and resources on this part. So that's it from my side. I don't want to spend much time on it, and just
I hope you are all
questions.
as impressed as I am. Oh my God, what a way of finishing the season 2 of online technology meetings. What an amazing way. Thank you so much for cooking food with lasers. Oh my God. I would like to thank, first of all, let everybody know that now we're going to have the one-on-one meeting, so please stay tuned. I took a lot of notes, almost as many as my colleagues. I took a lot of notes here, but my learnings that there is still huge unmet needs, but the end users in the room, they're open for cooperations. One of them was very clear. They look for more online automated measurements. They want to guarantee safety, quality, while increasing productivity. And they were very clear. Online sorting, that came from PepsiCo, online monitoring of cleanliness and authenticity. They want to have a reduced size and price of different sensors. Think about the hyperspectral imaging cameras. We need to go in the direction that they need to be integrated. And also from Marel, added value for the surface structuring, the one anti-adherent, so the chicken doesn't stick on the line, and antibacterial surfaces. We talk about photonic technologies with end users in the medical, in the food and beverage industry. We talk to them, and we talk to many end users on this season. You know what? That has been an amazing experience. When on the 1st of April, we came up with the totally crazy concept of online technology meetings, we didn't know what we had in mind. We didn't know that we were going to have 60 online technology meetings this year. All of them targeting end users and learning from them the different things that they can do. It's only 1 week to Christmas. If you want to get in touch with any of the participants of any of the online technology meetings, and there were 60, send me an email. I will make the introduction. This Christmas, only one thing: don't get out of your house. Stay home or wear a mask and wash your hands like our colleagues, but stay home and watch 300 hours of footage of online technology meetings prepared by the epic people on the medical, on the optics, on the laser, and on the quantum teams. They really have done a great job, and all the material is now on YouTube. On behalf of the whole team and on behalf of the 659 members of EPIC, just pay attention to the online technology meetings for Q1. Have a fantastic Christmas holidays, an awesome 2021. 2020 has been what has been, but it's almost over. A great 21, and wash your hands, wear a mask, because in 2021 we'll be traveling again. From Nordwijk, next to the sea, wishing all of you a Merry Christmas and Happy New Year. Bye bye.